Good morning children, myself Neelam. Today we are going to study chemistry subject, basically for 8th standard, ICSE syllabus, session 1. And the name of the chapter which we are going to deal with is matter. Simple one word chapter name which is matter, and it is chapter 1. Okay, now when I talk about the matter, right, this matter word you are hearing from since 6th standard. In physics subject also, even in chemistry subject also. This is very common and simplified word wherein you have to understand and have the awareness of this word, right? So what is all about the matter is nothing but anything, substance which has a mass and occupies space, called as matter. I repeat once again, anything, substance which has a mass, which is weighing with a certain weight and can occupy the space is called as a matter, right? Anything, the substance means whatever in the universe the substance are existing. Maybe that substance will have the life form, or it may be non-living being. Living being or non-living being, those substances are made up of a substance called as a matter, right? By the specific definition has been allotted with the matter. What it says that it has a mass, it is weighing with a certain weight, and it can occupy the space. That substance has a weight, right? It has a mass and can occupy the space. For example, let's take an example of one bench, right? The very desk, the bench on which you people are sitting, it has a mass, it can weigh to a certain amount, and it is occupying the space on the earth, or that is a non-living thing, right? The bench, the desk, the tree whichever it is, right? It is a living thing. So tree, human being, these are also considered to be matter. Human being, if I consider human being is also made up of matter. Suppose now if I am standing over here, I have a certain mass, I weigh with a certain amount, and I am occupying the space on the earth. So therefore, I myself also considered to be a matter. Understanding my point, right? Every substance is irrespective whether it is a living being or non-living being which has a mass, which weigh with a certain amount and can occupy the space on the earth, is nothing but called as a matter. The very air is also considered to be a matter, right? Because it has a composition of different matters, different gases, right? Apart from that, the rain, right? The water droplets which are coming from the cloud, pouring out from the cloud, the ocean, right? So whatever the substance which is existing in this universe, which has accurate mass to a certain amount and can occupy the space on the earth, those substances are considered to be matter. And this thing you are studying since from 6th standard, right? Now we are going to emphasize more into the matter. Now in 6th standard you are studying only the specific definition, what was the matter was all about, but you should know what was the matter was consist of, right? How the matter is made up, what is the main important constituent which is present in the matter, that you people should know it, right? Okay, now the molecule is a second terminology. We are going to study the terminology step by step, right? In terms that these are the content present in the matter, right? Now the second thing is molecule. Now this matter is there, no? The substance which occupies space and the mass, they are made up of a certain tiny particle, right? A matter is made up of a tiny particle called as molecules, right? The matter is made up of tiny particle called as molecule. For example, this is a chalk. Chalk is also considered to be a matter, right? Because it has a certain weight, right? It weight may be not in the kg, but in certain milligram or gram, not in milligram also, I'll consider in gram, right? So if it is weighing in certain gram, right, and it is occupying the space on my palm now, right? So this chalk is also considered to be a matter, right? So this chalk piece, which is a matter, which is a non-living being, a substance, is made up of a certain tiny particle within it, which is called as molecules, molecules. I repeat once again, a matter is made up of a tiny particle called as molecules, right? So for example, I said the chalk example, right? The chalk is considered to be a matter because it is occupying the space on my palm and it is having a weight of certain gram, but it is made up of certain tiny particle within it, which is called as molecules. So you people understood what is molecule? Molecule is nothing but the tiny particle present inside the matter. Okay. Now intermolecular force. You have to study about the intermolecular force over here. Now let's take an example. With the help of a diagram you will understand more better way. Right. Now this is a matter. The diagram which I had drawn over here, it is a matter. Thus this matter is made up of a tiny particle. Can you see the yellow color dots? These yellow color dots are nothing but these are the molecules. Right. So this is one kind of a matter, and this matter is made up of a tiny particle, many tiny particles will be there. You cannot count it, right? Many tiny particles which are called as molecules, right? So if one is there, if singular form is there, it is considered to be molecule. If many are there, that time we are said to be, we will consider as a molecules, plural form, right? So that is molecules, tiny particles which are called as molecules. Now this molecules, within this molecule there are certain forces. When one molecule is closer to the another molecule, there is a certain force, right? That force we need to understand over here. The molecules are held together. The molecules are held together by a force of attraction called as intermolecular force. Now when molecule is held together with another molecule, there is a force. And that force is considered to be inter means what? Between, right? So in between the molecule there is a force, and that force is considered to be intermolecular force, right? Inter means what? Inter means between, right? So between the molecule there is a force which is making them to held together. Suppose if one molecule is here, another molecule will be here. So these are little far away from each other. But these molecules are not going to remain loosely. They are going to held together. They will be having certain force of attraction between them, right? So that force is called as intermolecular force of attraction. That is the terminology. What is the intermolecular force of attraction? Intermolecular force of attraction is nothing but the molecules are held together by a force. If one molecule has to held together by another molecule, there should be certain force, and that force is nothing but called as inter. Inter means between the molecule the force exists, right? So that is intermolecular force. So the blue color arrows which I had made over there in the diagram is nothing but intermolecular force, right? So the force which is making the molecules to held together. Understanding my point? So that was all about the intermolecular force of attraction. So what we studied till now? We studied about the matter, right? What was the matter consist of? Matter consists of tiny particle called as molecules, and these molecules are held together by certain force of attraction called as intermolecular force, right? So that was all about the intermolecular force which was making the molecules to be held together. Now the next terminology is intermolecular space. I repeat, intermolecular space. Now what is intermolecular space? Now this term is also related with the molecule only. Whenever inter word is there, inter means between the molecule. Inter means between, right? So between the molecules. Now in between the molecules, see now suppose this is one molecule, another molecule here. So between the molecules there is a space, right? There is a gap. That gap is nothing but called as inter. Between the molecule the gap exists. So intermolecular space, right? So what is intermolecular space? The gap or the space which lying between the molecule is called as intermolecular gap or intermolecular space, right? So what the definition says? Intermolecular space. There is a space between the particles. Which particle? Molecule only, right? So there is a certain space between the molecule. That space is called as intermolecular. Again, inter means between. Between the molecule the gap exists. So intermolecular space. Right? Okay, that was a little terminologies. If you don't understand this terminologies, you won't be able to understand the two important point, which is very, very important. So let's recap these points once again. Now what was the matter? Matter is nothing but anything, substance which has a mass and can occupy space is called as a matter, right? Anything, it may be living being or non-living being which is waving with a certain amount and can occupy a space, that substance is considered to be a matter. Okay. Now second one is molecules. What is molecule? The matter is made up of certain tiny particle which is called as molecules, and this molecules has to be held together. This molecule has to be held together. These are the molecules, right? This molecule has to be held together by certain force called as intermolecular space. Inter means, you have to remember, inter means between. Between the molecule, the force is existing, right? So this force, why the force is existing? Suppose this molecule is here, this molecule is here. This molecule has to get connected with the another molecule. So there should be certain force of attraction. That force of attraction making the molecule to come closer to each other or held with each other. Right? In turn, it will make them more stronger. Understanding my point? Right? Okay. Then apart from that, there is a certain terminology, another terminology which is called as intermolecular space. Now what is intermolecular space? Again the same thing. Inter means between the molecule there are the space, the shadow, the shading ones which I had shown. This is nothing but called as a space. Space means gap. Between the molecule, the gap, empty gap will be there, and that gap is called as intermolecular space, right? So these are the terminology you people have to understand. First one is matter. Second one is you should understand intermolecular force of attraction. Third one is intermolecular space. So these three terminologies are very, very important over here. Okay. Now the two most important points, which is very, very important. Okay. Okay. Now what they are saying is, the stronger the intermolecular force, intermolecular force means the force of attraction which is lying between the molecule, right, which is making the molecule to be held together, right. The more stronger the intermolecular force, the smaller is the intermolecular space. If what it is saying is, if the intermolecular force will be more stronger, the space will be very less. Understanding my point, right? Suppose this is the matter. This is the matter. Now the molecules are residing into the matter, right? If the molecules are residing into the matter, there should be certain force. This is nothing but called as, what it is called as intermolecular force, right? These are intermolecular force of attraction. If this intermolecular force of attraction are more stronger means the molecules will no more move apart from each other, right? They will be more strongly held with each other. Then the space between them will be very less, right? I repeat once again. Now if this matter is having the molecules, right, many molecules are there and they are very close together. If they are close together, the force of attraction is very strong, right? The strong force of attraction is there between the molecule, the space will be very less, right? That's a common sense. I repeat once again. If the stronger the intermolecular force of attraction, lesser will be the space between them, right? Lesser will be the space between them. They will be having very, very tiny or minor space between them, right? Which is called as intermolecular space. I repeat, the stronger the intermolecular force, the more the intermolecular force, less will be the intermolecular space. So the space between the molecules will be very less because many molecules will be held together by that intermolecular force, right? Now second statement. Second statement, what it says, contrasting to the upper one. Weaker the intermolecular force. Suppose another matter molecule I will take. Another matter will take. Now suppose one molecule is residing here. Another molecule will be residing here. Another molecule will be residing here. So the force of attraction between them is weak because they are little far apart from each other. Since they are little far apart from each other, the intermolecular force will be weak. Right? So weaker the intermolecular force, more will be the space. right? More will be the intermolecular phase or larger will be the intermolecular phase, right? That is there. So first one is saying stronger the intermolecular force, when the molecules are held together with a stronger force, less will be the space, less will be the intermolecular space. Otherwise, if the molecules are far apart from each other, then they will possess the weak force. If the molecule is here and the molecule is another molecule is here, they will be having weaker, intermolecular force. If the intermolecular force is weak, they will be having more gap, more space, intermolecular space. So that's the statement is saying about. These are the two important statements. First statement, if you understood, second statement will be exactly opposite or contrasting to the first statement. I repeat once again. More stronger the intermolecular force. If force will be more, gap will be less. That's it. If force means which force? Intermolecular force. If force is more stronger, less or weaker will be the space, intermolecular space. Right. Second one is if weak intermolecular force is there. Weaker the intermolecular space, larger will be weaker the intermolecular force, larger will be the space, because the molecules are residing at very pole with each other, right? Far apart from each other. Therefore, the force of attraction between them will be weak and more intermolecular space will be there, right? So these are very, very important two statements, right? So what we studied over here, we studied about the matter, right? What was the matter was all about? What does the matter made up of? Matter is made up of a tiny particle called as molecules. Apart from that, we studied about the force. What is the force? Which force? Intermolecular force. Where does this intermolecular force resides or stays or situated? Intermolecular force is situated between the molecule. Inter means between. So between the molecule, this force will be there. So the molecules are held together by a force called as intermolecular force. Now what was intermolecular space? Intermolecular space is nothing but the space which is lying between the molecule, right? There is a space between the particle of molecule called as intermolecular space. Okay. Now apart from that, we studied a very important 2 points. First one was saying that more stronger the intermolecular force. If more stronger the intermolecular space, force, lesser will be the space. Lesser will be the intermolecular space. Repeat once again. Stronger the intermolecular force. Here, stronger the intermolecular force, smaller will be the space, or lesser will be the intermolecular space over there. It's really very common sense over there. If many molecules are held together, they will be having stronger, they will be having very stronger intermolecular force, right? If they are tightly held together, less space will be there between them, less intermolecular space will be there. Then contrasting to that is, if weaker intermolecular space, force is there, one molecule is residing here, another molecule is residing little far apart from each other, right? So they will having the force which is weak, right? If weak force of attraction is there, then the space between them will be more, right? Then the intermolecular space will be larger. So this is very, very important, children. They may ask you in the fill in the blanks, or they may ask you to write a short note upon the interrelationship between the intermolecular force and the intermolecular space. So you should know the interrelationship between them, right? And now we need to study or emphasize upon state of matter. Earlier we have been studied or gone across the important terminologies. Those were matter, molecules, intermolecular force, and then intermolecular space. So these 4 terminologies are very, very important over there, right? Then apart from that, we need to emphasize now or study about the state of matter. Now how many states of matters are there, right? You guys are knowing since from lower standard itself, maybe from primary section only you are studying this state of matters, right? There are 3 states of matters. Let's recap once again, no worries about it, right? First one is solid, second one is liquid, third one is gaseous, right? So these are the 3 states of matter, right? But we in earlier section, when we are younger or when we are studying in lower classes, we were studying only upon the state of matters, but we were not knowing that the matter was made up of tiny particle called as molecule, and between that molecule there is a certain force which is called as intermolecular force, and there should be certain gap between the molecule, which is called as intermolecular space, right? Now when we enter into 8th standard, we studied, right? Then apart from that, the most important concept over which arises over here is what causes the difference in this state. What is the main differentiating point which is differentiating solid from liquid, liquid from gas, right? So there should be certain factor, right? There should be certain factor which is differentiating solid matter from liquid, liquid matter from gas. Why solid is considered to be a solid, why liquid is considered to be liquid, and so on. That's for gas, right? Now let's talk about the solid. What does the solid consist within it, and how the intermolecular force arises between them, and about the gap, means the space, intermolecular space, right? Now when I talk about the solid, what thing comes first to your mind? Solid is very rigid, right? It has a certain shape, it occupies the volume, it has a volume also. Now let's talk about the chalk. Chalk is a solid, right? Now this solid is rigid, right, hard. Apart from that, it has a certain shape also, it will have volume also, right? Solid is having all these properties. So if it is having certain this all property, there should be certain factor which is making those property to accomplish it, right? So what are those factors? Let's understand that. So the intermolecular force, now we will talk only about the solid state of matter, right? So for that we need to understand the intermolecular force point. Apart from that, the gap, the space which is lying within the molecule, which is that space, intermolecular space. So for all these three state of matter, these two important keywords are very important over there. First one is intermolecular force, second one is intermolecular space. Intermolecular force was the force which was making the molecule to held together. Intermolecular space is the gap or the space which was residing between the molecule, right? Okay, now what will be the force behaving, how will be the force will be behaving in the solid matter? So the intermolecular force in the solid is the strongest, right? So the intermolecular force is the strongest in the solid. So if I talk about, now let's take the example, with the help of example or with the help of a diagram, we'll understand, right? So what they're saying, the intermolecular force is strongest in the solid. Now these are the molecules of solid. So whatever I drawn with a round shape, which is called as molecule, because matter is made up of a tiny particle called as molecule, right? So solid is a matter over here, right? Solid is a matter because there are three states of matter. We are studying the state of matter, right? So solid is the one state of matter over here. So these tiny particles which I had represented with the yellow chalk is molecule. Now these molecules are having certain force. There is a intermolecular force which is lying between the molecule, right? But this intermolecular force is very strong, right? Because one molecule is very much adjacent to the another molecule, which is making them to attract, or the force of attraction between the molecules in the solid state will be the strongest, which is making them hard and rigid in shape, right? Okay, so what they are talking is the intermolecular force. The intermolecular force is strongest in the solid state. You can see with the diagram only, right? Then if the intermolecular force, if the force is strong, then what about the space? What will be about the intermolecular space? The intermolecular space is the smallest in the solid state, right? So if the force is strong, can you have any space over here? The space is very small. Can you see over here, right? The space is very small. The intermolecular space is small, smallest space. Why the space is small? Because the force is strong. More the molecule is compact with each other, greater will be the force of attraction between them, right? Since the force of attraction between the molecule is very strong, the gap between the molecule will be very smaller, right? So they are vice versa to each other. Understanding my point? So what the molecule was saying, what the solid state was saying here, the intermolecular force is stronger. The intermolecular force, the force of attraction between the molecule is stronger. Why the force of attraction between the molecule is stronger? Because they are very closer to each other. The molecules are very closer to each other. If the molecules are very close to each other, force of attraction will be stronger and if the stronger force of attraction is there, the gap will be very less. That's the thing, right? So therefore the solid is having rigid shape because the molecules are very close to each other, since their intermolecular force is very strong with smaller intermolecular space. That's all about the solid state. Okay, now let's talk about the liquid state. Now solid state example, you know everything, whatever, the board, the chalk, right, the decks, the table, the fan, the tube light, all are solid in the state of matter for them is solid, right? Okay, now let's talk about the liquid, right? Now in liquid also, the liquid is made up of tiny particle called as molecule, because liquid is also considered to be a state of matter, right? So if this is a state of matter, right, the molecule which have been represented with the yellow chalk, those are very tiny. But you can compare the diagram between the solid state and the liquid state. In solid state, you can see the molecules are held very close to each other. They are very close to each other, right? The molecule in the solid state. But in the liquid state, the molecules are little away from each other. They are little away from each other, right? Okay. Now, if they are little away from each other, the space is there between them, right? If the space is there, then what about the intermolecular force? That we need to understand, right? Okay, let's talk about it. The liquid, okay, in liquid state what happens? The intermolecular force is weaker. The intermolecular force is weaker. Since the molecule are little far, little away from each other, the force of attraction between the molecule is weak because the molecules are little far away from each other, right? So here three, words are there: stronger, weak, and weakest, right? Strongest, weaker, and weakest, right? For liquid state we need to represent with the weaker, because when I talk about the gaseous state, that time weakest will be there, right? So here in the liquid state, the intermolecular force is weaker. Why it is weaker? I am not using the word weakest. Weakest will be more weaker, right? So here it is weaker. Since it is weaker, right, the space will be more, no? The space between them, you can see with the diagram only, the space, the intermolecular space is more, larger. The intermolecular space is larger. Why the intermolecular space is larger? Because one molecule is, residing here, the another will be little away from the first one. So thereby the intermolecular force of attraction between the first molecule and the second molecule will be weak. And thereby they are having the intermolecular space or gap between them, right? So in the liquid, for example, liquid, right? A liquid like water, juice. So these are liquid state of matter, right? So why they are considered to be liquid state of matter? The molecules are little far away from each other. If they are far away from each other, the force of attraction between the liquid is weaker and the intermolecular gap or the space will be larger. That's there, right? So that was all about the liquid state of matter. For example, water, juice, different kind of a liquid, foodstuff. Okay. Then we'll talk about the third state of matter. Now the third state of matter is gaseous state, right? The gaseous state, the air, right? For example, when you blow the air inside the balloon, how the gaseous molecule will behave over there, how they will be away from each other. What about the intermolecular force of attraction between the gaseous molecule in the air when you blow inside the balloon, right? So let's talk about the gaseous state, right? Now gaseous state is also a state of matter. So since if it is a state of matter, it will be made up of tiny particle called as molecule. Now these are the yellow color molecule. The yellow color molecules are represented over here in the diagram, right? So now in the gaseous state, what you can see over here, in gaseous state I can see clearly that the one molecule is residing in one pole, the another molecule is residing on the another pole, right? They are so far away from each other. They are so far away from each other. Since they are so far away from each other, the intermolecular force of attraction will be weakest. Weakest, I am using the word weakest. Weakest means more and more weaker. Understanding my point? Why they are more and more weaker? Because if one molecule is there, the another molecule will be downside or other pole. Understanding? So the force of attraction between those molecules will be more weakest. Understanding? If the force of attraction is more weakest, then what will be the space? If they are residing in the one pole and the another pole, there will be more gap, more space. So largest will be the intermolecular space, right? So what the statement say, let's see. The intermolecular force is weakest. The intermolecular force is weakest because the molecules are residing in opposite poles, far away from each other. So the attraction between the molecule is very, very weak, right, in the gaseous state. Then what about the space? If they are residing in a very, far apart from each other, the space between them, the intermolecular space will be larger. Means they will be having the largest intermolecular space in the gaseous state. So this becomes very clear with the picture that the state of matters are differing with each other because of the two factors, intermolecular force of attraction and intermolecular space. Though all these molecules, all these substances are having the same, maybe they will be made up of same substance or same molecule inside it, right? Now suppose if I take the solid component like chalk will be having the same molecule within it, right? This solid will be having the same type of molecule will be present, same type of molecules will be present, right? Here also in the liquid state, if I take water will be having H2 molecule within it, right? This water liquid will be having the same molecules within them. So molecule does not making any matter of changing the state of matter. What is making the factor to change the state of matter is two keywords, which is intermolecular space and intermolecular force of attraction. These two keywords are making the difference in the state of matter, not the molecules which are present within the state of matter, because they might be made up of same molecules. They might be made up of same molecules, but these two keywords are making them to differ from solid to liquid, liquid to gas, right? Okay, what was making the difference between the solid, liquid and the gaseous state was the two keywords, intermolecular space and intermolecular force of attraction. These two keywords are very, very important over here, children. So from the diagrammatic representation we can easily see, right, here in little recap about the solid state, liquid state and the gaseous state. In solid state, what was you were seeing that the intermolecular force was very, very stronger and space, intermolecular space is weaker, right? Then whereas in liquid, when you compare solid with a liquid, there you can see the intermolecular force is weaker. Intermolecular force is weaker because the molecules are little far away from each other. Thereby, then what will be the larger over here? What will be the larger? The space in or the intermolecular space will be larger in the liquid state, right? For example, water molecule or any liquid foodstuff, right? Apart from that, in the gaseous state, since the molecules are far apart from each other, right, the intermolecular force will be weakest. In solid, the intermolecular force is strongest. In liquid, the intermolecular force is weaker. In gaseous, the intermolecular force is where it is weakest, right? So these are the three words. Intermolecular force of attraction in solid is strongest. Intermolecular force of attraction in liquid is weaker. Intermolecular force of attraction in gaseous is weakest. Why it is weakest? Because the molecules are far away from each other. Gas, when you blow the air inside the balloon, what will happen? When you just unwind the thread over there, immediately the gas which is filled inside that, it will be going to get released out, because the molecules are more randomly moving here and there, because the space between the molecule is larger over there in the gaseous state. So these are the three important state of matter which is going to get differ because of intermolecular force of attraction and intermolecular space. Though the substance or the molecule which will be present in this three state of matter will be same. Now solid state, for example, chalk, I said, chalk or any desk, wooden desk, if I take, wooden desk will be made up of wood inside it, wooden molecule over there, the same kind of a molecule will be present, but solid is differing from the liquid. If the liquid water is made up of same molecule, water molecule inside it, but why the difference in the state of matter? The state of matter is differing because of this two important keyword, intermolecular force of attraction between the molecule and the intermolecular space between the molecules. So that was all about the state of matter, the differentiation between these three state of matter. Okay, thank you.